Dear students, now we are going to discuss small signal analysis of common emitter amplifier using hybrid pi model. For that we can consider a common emitter amplifier circuit with a voltage divider biasing method. So in this one, Vs represents the voltage signal source, Rs is the source resistance. Okay. Then the coupling capacitors at the input and output sides are mainly used to provide the proper DC isolation. Okay. R1, R2 and RE resistors are used to provide the proper DC biasing to the transistor. Here this R1 and R2 form the voltage divider circuit at the input side. The next one is bypass capacitor. So this capacitor is connected in parallel with this emitter resistor to provide the low reactance path to this amplifier circuit. So why do we need this bypass capacitor here? If it is not used in the circuit, the amplified AC signal is also passing through this emitter resistance. If it is passing through this emitter resistance means there may be some voltage drop across this emitter resistor. So this will reduce the output voltage, in turn reducing the gain of the amplifier. So in order to increase the gain of the amplifier, the bypass capacitor is connected in parallel with this emitter resistor. Do you all understand this one? So next we are going to draw the AC equivalent circuit for this CE amplifier. So here we need to follow certain steps. The first one is we have to remove the DC effects of the supply voltage VCC by grounding it. So there is no VCC supply voltage, we have to simply ground it. Okay. Next, the coupling capacitors and the bypass capacitors, all the capacitors are short circuited here. As the bypass capacitor bypasses the emitter resistance value, here we can simply remove this emitter resistance also. So this is the simple steps to be followed in this one. In the next step, we are going to replace transistor with its hybrid pi model, and R1 and R2 both are in parallel. We can combine these two resistors. Okay. Next, small signal equivalent circuit of CE amplifier. In this, voltage signal source in series with source resistance. R1 and R2 both are combined together to form a single element, R1 in parallel with R2. Next, the transistor is replaced with its equivalent hybrid pi model. So in this pi model, three parameters are important one: R pi, GM and RO. R pi represents the small signal base emitter internal resistance. GM is the transconductance which relates the output current with the input voltage. Okay. So next, RO, it represents the output resistance which includes yearly effect. Okay. So in this one, the input resistance is nothing but parallel combination of R1, R2 and R pi. So parallel combination of these three resistance value is input resistance. The output resistance is nothing but the parallel combination of RO and RC. Okay. So we can discuss this concept here. R pi, it is also called as diffusion resistance. It relates the small signal input base current to the voltage. So R pi is equal to, according to Ohm's law, voltage by current. So input voltage is VBE by IB. The base current is nothing but IBQ by VT into VBE. So what is mean by this IBQ? So we are going to concentrate the input characteristics for getting this R pi value. So here we can draw the circuit like this: VBE versus this IB. This is the input characteristics. In this one, we can have the input characteristics like this. Okay. So this is the Q point. Then we can get IBQ. This one is VBEQ. Okay. That is Q values. This slope is nothing but 1 by R pi. From this we can get small signal base current is nothing but this base Q value divided by VT. VT is nothing but the cut-in voltage of the transistor, that is 0.7 volt for silicon. Okay, which is multiplied with VBE. Then we can cancel this to 1. We can move this Vt to the numerator to get R pi value as Vt by IBQ. As we all know that beta, that is current gain, is equal to output current by input current. Here we have to consider only the Q point values. Okay, in this we can get IBQ is equal to ICQ by beta. We have to substitute this value here. So Vt by IBQ is replaced with ICQ by beta. Then we can get R pi value as beta into Vt by ICQ. So this is the R pi value. So next one is transconductance. So it relates the output current to the input parameter Vt. So Gm is nothing but what? ICQ by Vt. Next we are going to analyze the characteristics of CE amplifier. The first one is input resistance Ri. It is the parallel combination of R1, R2 and R pi, correct? So next one is voltage gain. Voltage gain is defined as the ratio of output voltage to the input voltage. So what is the value of this output voltage from this equivalent circuit? So here this output voltage is equal to Gm V pi into the resistance. Resistance is nothing but what? Ro parallel with Rc. Since the direction is plus to minus, we can get this output voltage Vo is equal to minus Gm V pi multiplied with this parallel combination. Okay, so that's what given here. The output voltage Vo is equal to minus Gm V pi into Ro parallel with Rc. Here this capital letter represents the characteristics of the amplifier. Small r represents the small signal internal resistance value. Okay, that is the difference over here. So next we are going to find out the V pi value from the input side using voltage divider rule. So in this equivalent circuit, V pi is equal to, what is the total voltage? Vs multiplied with parallel combination of this three, correct? Using voltage divider rule, this V pi is equal to Vs multiplied with R1 parallel to R2 in parallel to this R pi divided by the whole resistance at this input side. So that's what given here. V pi is equal to R1 parallel with R2 parallel with R pi divided by this value plus Rs. Here we have to include the source resistance multiplied with Vs. So in this, the parallel combination of R1, R2, R pi represents the input resistance Ri. Then we can write V pi is equal to Ri divided by Ri plus Rs into Vs. So this is the V pi value. We are going to substitute this V pi value in this V naught equation. So this V pi is replaced with this value here. So then we can get Vo is equal to minus Gm Ro parallel with Rc into Ri by Ri plus Rs into Vs. Then we have to simply move this Vs to this left hand side as a denominator. Then we can get Vo by Vs. That is nothing but voltage gain. Correct? That is equal to minus Gm Ro in parallel with Rc into Ri by Ri plus Rs. So this is the voltage gain of the CE amplifier. Okay. Next, current gain of CE amplifier. It can be obtained by multiplying R pi and Gm. So here R pi is equal to beta Vt by ICQ. Gm is ICQ by Vt. Then we can simplify these terms. We can get the beta value as R pi into Gm. Okay. The output resistance of the CE amplifier is given as Ro in parallel with Rc with the condition the source is independent. Advantages of small signal analysis. It is a simple and easy method. It is convenient to use in circuit analysis. The required parameters like R pi, Gm are readily available with the circuit. Okay. So in this method, the equivalent circuit consists of simple approximation with its important features. Here we can simply ignore the other less important qualities. Okay, so we have to consider only the important features for our analysis.